Here we have the data of a sample of radionuclide iodine 128. We have the timing data, and we have in the other column the counts data. And our objective is to plot it on a semi-log scale. We will set y-axis, the counts axis, to be logarithmic. So let's see the values. So these values are up to say 400, and they goes down up to 1. So 1 to 400. Okay. And the x-axis is from 4 to say 250. So let's set the scale on the graph paper. So the first one is the x-axis. X-axis, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 20, 30. So I can go up to, if I consider, well, these are 3 major divisions, and the time is from 4 to 218. So let's set x-axis the one major division to 100, the second would be 200, and third would be 300. So the time would be rightfully captured in this scale. So I write some numbers. It's better to use the text. Okay, this one is 0. And this one is 100. This one is 200. And the final division is going to be 300. This is the linear scale. There is no problem with this one. Everybody knows about it. This is the time. Time is in minutes. All graphs must have the axis labeled. Now the vertical scale, we require the values from about 400 to 1. So let's set this one vertical as 1. And well, I wish to scroll. And starting from 1, this is also, this will be 10. And the next upper level will be 100. This 10 will now represent 100. And then, okay, it will go up to the final mark 1000, right? The semi-log scale, right? And now let's start plotting the data. So for this very purpose, I will take the points, and I will show with the, okay, this would be rather more visible. Okay. So the first point is 4 and 392. And 392. So first one, so our larger division is 100. So 1 represents 10. So it will be somewhere middle in the first box, and I have to go up to 300. Okay. So 100, 300. So 300, and this mark is 400, right? So 392 would be somewhere here. So let's draw this point here, approximately, right? Then the next point is 36 and 161. 36. Okay, 10, 20, 30, 36 would be somewhere here, and going up, 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 up. 161. Okay, please notice, well, 10, 20, 30, 40. So this is 200. I have to plot the data as 161. So this is 100. This is 200. So you can right, how to read that. 110, 120, 130, 140, no, it's not like that. It's not like that. The interpolation on logarithmic scales is very, very difficult. So it should be somewhere above the middle between 100 and 200, right? So approximate point for the time being, let me draw it here. Then I plot the point 100 and 26.8. So 100 is one larger division. Okay, this one 100 is 26.8. 26.8. The 100 line on x-axis, and this is 10 on vertical axis. This is 26.8. So it is 20, it is 30. So above the 1/3, no, 2/3, right? It is 26.8. So I plot this point somewhere. Okay, right? Then one more point, 218 and 1. Okay, that's going to mark a corner one. Okay, 218. So 200, 220. So somewhere and 1, right? 218. This is 210, 220. Okay, okay. So 18 would be somewhere here, and 1 is there. So the point will be located at this point, somewhere here, right? So you can also then draw the interior points on similar lines. Okay, at this level we can see all the points, right? 3 points that we have attempted, and our wish, and from the theory, these points can be approximated by a straight line on this graph paper. Let me attempt that straight line. But behind this straight line actually is the regression analysis, which helps you to draw a unique straight line which approximates this data with the straight line. So I attempt. Oh, very dangerous experiment. Oh, okay. So pardon for this line. It's very difficult to control on the laptop, right? Okay, that's the way we interpret the logarithmic scales. So take a deep breath. It calms the mind.